Now we are going to start the chapter 3rd, that is Binomial Theorem. That is, we are going to say that as we are familiar with expression like a plus b whole square, a plus b raised to power 1 is a plus b, and a plus b whole square is equal to a square plus 2ab plus b square, and a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube, and a plus b raised to power 4 can be found out by using a plus b whole cube into a plus b, or either a plus b whole square into a plus b whole square. So we will get the result a raised to power 4, 4a cube b plus 6 a square b square plus 4 ab cube plus b4. So as the expression of type a plus b raised to power 5, a plus b raised to power 6, and so on become difficult by using multiplication. So then in 11th century, Persian poet and mathematician Omar Khayyam gave the general formula for the expression a plus b raised to power n, where n is a positive integer, and this formula is called binomial theorem. So also, to make it easy, the coefficient of the consecutive terms in the expansion of a plus b raised to power n for n is equal to 1, 2, 3 and so on can be obtained from a row from a triangular arrangement of numbers known as Pascal triangle. That is, let's see how it can be happen. Write here index, that is n, and here are coefficients. If n is equal to 1, we have nc naught, that is 1c naught and 1c1 as coefficient. So we have these two coefficients. When the index is 2, so we have 1 again here and 1 again here, and in between 1 plus 1, that is 2. So it comes out to be by adding these two. So it is 2c0, this is 2c1 and this is 2c2 coefficient. Now let's see when n is equal to 3. So it is 1 and 1 here, and we have 1 plus 2 on adding, that is 3, and 2 plus 1 on adding gives 3. So it is 3c0, 3c1, 3c2 and 3c3. That is the coefficient of binomial theorem when n is equal to 3. So when n is equal to 4, we get 1 here, 1 and 3, that is 4, 3 and 3, that is 6, 3 and 1 is 4, and 1 is as 1. This is going like this. This arrow is going like this. 1 is again stated at 1. So if we see here, we have 4c0, 4c1, 4c2, 4c3 and 4c4. So just going down like in this manner. By adding these two factors and giving the new one, 1 is as 1, and by another by getting these two and adding these, we get next factor, next coefficient, next coefficient, next coefficient. So if we see, we get the Pascal triangle like this, that is for index and coefficient. We get for n is equal to 1, it is nc naught, 1c naught and 1c1. And for index 2, we get 2c naught, 2c1, 2c2. So for index 3, we get 3c naught, 3c1, 3c2, 3c3. So index 4, we get 4c naught, 4c1, 4c2, 4c3 and 4c4. That is, arrow is going like this, and next arrow will be this, that is 5c naught and 5c5. Another one are by adding these two arrows, by adding these two arrows, by adding these two arrows, and next will be by adding these two, by adding these two, by adding these two, and continuing in this manner. We will get the coefficient of other index. So we see that in every row, first and last, element of any row is 1, while the other elements are obtained by adding the number of upper row which are at the beginning of arrow. That is first and last element is 1 and other elements are by adding the upper element which are beginning of the arrow to get the new coefficient of next index. It was all about the Pascal triangle. If you want to verify, so verify for first row, that is we have 1C0 plus 1C1. That is according to formula NCR minus 1 plus NCR is equal to N plus 1 CR. That is 2C1. So on adding these two, if you see, that is this and this, we get 2. And we check out the value by the formula of combination. You can also check out. That is, we know that NCR is equal to N factorial over R factorial into N minus R factorial. Therefore, 1C0 is 1 factorial, 0 factorial, 1 factorial, that is 1. As 0 factorial is 1. And 1C1 is 1 factorial, 1 factorial, 0 factorial, that is also 1. And what about 2C1? 2C1 is 2 factorial, 1 factorial into 1 factorial. So we get, that is 2 into 1, that is 2. So sum of these two is 2. So by you can check out at every row. If you get row third, so the third row is 1, 3, 3, 1. First and last element is 1 and this is obtained by, that is sum of first and second term, that is 1 plus 2, that is NC 2C0 plus 2C1, that gives 3 and 3 is 3C1. So this is true. And also element 2 plus 1, that is 2C1 plus 2C2, that is 3, that is 3C2. So this is also true. So by using the above criteria, we get the Pascal triangle in the combination coefficient, that is C0 combination. So as see above, we get that array. So from above array, it is clear that we can write the coefficient of terms in the expansion of a plus b raised to power n. So for any index n, that is take n is equal to 7, we can write the coefficient as 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, 7C7. So we can find out the coefficient in this manner by using Pascal triangle. So now in the next topic we are going to state and prove binomial theorem.